G'day guys, I've been requested to do a video on how to convert from degrees to radians and obviously from radians back to degrees. Now there's a heap of videos on YouTube like this, but I thought, if I'm going to do a video, the way I can be different is to try and give you guys a ground up explanation on how to do this that will eliminate the need for you guys to rote learn or memorize any formulae. And as a result, it'll eliminate the possibility of you guys, making a mistake due to, you've divided rather than times when you're going the one way and times rather than divided going back the other way. So let's get to it. The only thing that you're going to have to remember when you're converting from degrees to radians or from radians back to degrees is one sort of simple thing, that a full circle in degrees is 360 degrees, and that's equivalent to 2 pi radians. Now, if you know that, then you can solve any of these problems. That's the only thing I'm asking you to remember. So you learn that 360 degrees is a full circle basically when you're 12 years old, maybe even earlier. So all I'm asking is that you can match these two or make these equivalent. And what we're going to do, the method that I'm going to use to convert all of these from degrees to radians or radians back to degrees is using ratios. Now, let's get to it. The way that I'm going to do the first one, so we're going from degrees back to radians to start. So let's just underline that. So we've got 135 degrees and we need to figure out how many radians it is. Well, what I do is I work out, what is 135 as a fraction of a full circle? So I go 135 over a full circle, 360, and I know that's going to have to be equivalent to whatever my radians are over 2 pi. So I'm trying to solve for x here, guys. So what I then do is I can simplify this. I know that 45 goes into both of them. So I can say, well, 45 goes into 135 3 times. And 45 goes into 368 times. And that's equal to x over 2 pi. Now let's take it up here. So what we've got now is I'm going to just use a bit of algebra. I'm going to take the 2 pi up to the numerator on the left-hand side, and I'm going to have 3 times 2 pi over 8 equals x. So I then can just simplify this again. 3 times 2 is 6. 6 over 8 is equivalent to 3 over 4. So that's going to be 3 pi divided by 4 equals x. So what we know is that 135 degrees, let me just change colour, is equal to 3 pi over 4 radians. Now, what you'll notice is that, yes, this method takes a little bit longer and requires a working knowledge of how to do algebra, but there's a lot of benefit to be gained in being able to do these kind of quick degree to radians calculations, which you know are always going to be right. Because in later years, what you're going to need to be able to do is this is going to be assumed. So that you're not going to get any questions which say, please convert this many degrees to radians. There's going to be a degrees value, and the question is going to be such that you will require radians to solve it. So if you still getting confused in how to convert from degrees to radians in later years, you're not going to have a very good time. So spending a little bit of extra time working on these now will pay back in spades later on. Okay, well, let's go to the next one. This one's going to be a bit more tricky, but we're going to use exactly the same method. What I'm going to do is I'm going to go 68 degrees over 360 equals the amount of radians we're trying to look for divided by 2 pi. We then simplify this 68 over 360, so 2 goes into both. It's going to be 34 on 180. 2 goes into both. 17 over 90. Okay. So this is going to be 17 over 90 equals x over 2 pi. Pi is pretty average. Okay. So, again, let's move it up here. We then use our algebra to move the 2 pi up to the top, and we have cool. Now it's just a case of simplification. This 2 pi over 90 we can convert to 1 pi over 45. So we have that equals x. So we could have 17 pi on, so we could actually leave it as that, to be perfectly honest. We could say that this, so like x is equal to 17 pi on 45 radians, if you wanted to leave as an exact answer, but sometimes it's worth just to convert it to a, approximation. They're fairly accurate approximations because you can go to as many decimal places as you want. I'll go to 3. So this is just going to be 1.187 radians. So you can see that just by getting the fractions and using a little bit of algebra, you can get an exact value or you can get an approximation depending on what the question is asking. All right, so let's go to the next one. We're going to go backwards now from radians back to degrees. So let's just change color. I've got 1.5 radians. So instead of going the amount of degrees over 360, I'm going to go the amount of radians over 2 pi. So I'm going to go, well, this is going to be equal to 1.5 divided by 2 pi, and that's got to be equal to the number of degrees that we have divided by 360. Now, like we did in the other one, I'm going to move the 360 up here. 1.5 times 360, 1.5 terms is 540. So 540 over 2 pi has to be equal to x. Now, half of 540, we've got 250, 270. So we've got x is equal to 270 over pi, which is equal to about, well, depends how many, again, that's going to be our exact answer, or our approximation, we can say is 85.944 degrees. So that's like, some questions will actually ask you for an exact answer. So if it asks you for an exact answer, you can literally say, well, we have the exact answer for 1.5 radians is 270 over pi degrees. Like, you can write that as an exact answer if it's asking for it. But when it's talking about degrees, usually they don't like it in terms of pi. You can just leave it as 85 point something or other, or if you wanted to, nearest degree is 86. Okay, so the last one here, we have 11 pi on 12 radians. Now, for me, I would prefer to be converting the second one than the first one, but that's just a bit of personal preference. Okay, let's change colors again, because what we have is we have 11 pi on 12 third time's a charm, 11 pi on 12. Now this is going to be divided by 2 pi. So let's just go, like, rather than putting it on a fraction, let's go divided by 2 pi has to be equal to the amount of degrees we have divided by 360. Now dividing by something is like multiplying by its reciprocal, so I can go 11 pi over 12 times by 1 over 2 pi equals x over 360. So what I have is I'm going to then say, well, 11 pi on 12, 12 times 2 pi is 24 pi. So I'm going to have 11 pi over 24 pi equals x over 360. Now what you hopefully all you guys can see is that the pi's will cancel out, which is nice, to be perfectly honest. So, going back up here, so we have 11 over 24 equals x over 360. Cool. So, we can just do a bit of algebra now. We can just take the 360, multiply it up to the top. We have 11 times 360 over 24 equals x. I know that 12 goes into 24 and 360. It goes into 24 two times, so we've got 11 times something over 2. It goes into 360 30 times, equals x. 30 divided by 2 is 15. 11 times 15 is 165. So x is equal to 165 degrees. So you can see that gives you a nice round number. So let's have a look at what we've done here. Basically what we've used is we've used ratios to be able to convert from both radians to degrees and degrees to radians. Now, the reason why I like this method is because when I first started doing these conversions back in high school, I used to get confused which one I had to times, which one I had to divide by 360 or 2 pi or whatever. So what I was told by a tutor of mine at university is to do these conversions using simply these ratio techniques. You get the fraction that your degrees are over 360, or the fraction that your radians are over 2 pi, and then you equate that to whatever your fraction is in the other unit of measurement over 2 pi or 360. And when you do it, then you can just solve for your x value that you're looking for. And if you know how to do algebra, a simple algebra, and you don't make that many silly mistakes, you can get this right every single time. So, I would recommend doing it this method, guys. If you don't like it, well, that's your prerogative, and I'll see you again next time.